Let us solve the exercise number 3 in the part A of our data structure lab. In this exercise, we are supposed to write a program to solve the Tower of Hanoi using recursion. So this is what we are supposed to do. So before we solve the problem, let's first understand what is this Tower of Hanoi, and then we will try to derive the solution for that problem. The Tower of Hanoi is very simple problem. We have set of disks that are there in one of the pole, and we are supposed to move this set of disks from one pole to the other pole. So from the source to the destination. However, there are few restrictions that are there for this movement. One of the restriction is that at a time you can move only one disk. So and that disk must be the topmost one. So in other words, I cannot move this disk, this is one disk, directly to the other side. That is not allowed. So if I want to move this one, I have to somehow to see to it that the top one is moved first, and then this has to be moved elsewhere. The next one is when you are moving, we can make use of an auxiliary or a temporary pole to keep the disk temporarily in this auxiliary pole. But at any time when you are moving, either for the end or in the auxiliary, you cannot have the larger disk sitting on top of a smaller disk. So if you look at here, this disk, the green disk, is smaller than the orange disk. So that is yellow disk. That is not allowed. So you cannot have this scenario wherein the smaller disk is there at the bottom, and on top of it you get the larger disk. However, this situation is perfectly valid, wherein you have larger disk, on top of it smaller disk is kept. Now let's try to solve the problem. So we know that what is the Tower of Hanoi problem. So let's try to find the solution for the given problem. So for the solution, let's start with the simplest one. So let's go and let's assume that we are the luckiest one, and there is only one disk which is there in the pole, that is in the beginning, and we are supposed to move it to the end. When there is only one disk, you can simply take this disk and put it onto the other pole, and that is the solution. We solved this problem. So in other words, you are directly moving from A, you are directly, or from the beginning, whatever you call it as, you are directly moving it to the end. So when there is only one disk, that is when the count of disk, suppose if you say n is the count of disk, if the count of disk is 1, just move the disk from A to C directly. There is no need to use any auxiliary pole, or that is there is no need to use a temporary pole. So let's quickly write this one as the solution, and then we try to complicate the matter. I have with me the code block, and I'm going to go and start a new program here by clicking on the file and the new, put it here, and let me, not this one, I'm going to say file. Instead of that, I'm going to just click on this one. Okay, that came in between, that's why I got confused. I'm going to click on this icon over here, that is the new icon here, and I'm going to just select the file as my option. So this is the option I'm going to select. So file as my option. Okay, file as my option, and then I'm going to select C and C++ source. Click go, and I'm going to click next, and I will select C as my program because I'm going to type it in C. Go to the location where you want to save the file and just give the name, and I'm going to give the name as Hanoi. You can give any name. Let me click on save, and let me finish it up. So you have this one. As usual, I'm going to use the include stdio.h because I need some input output operation. Okay. So let's write a function. So what is this function that we can think of writing? So this function is, let us give a name to this function. You can give any name. I'm going to call this one as, you can call it as Hanoi or Tower or anything. So let me use the word tower because you may not get the spelling. So what are the things which are there in this whole story? You have n number, even though I have started with the one, you have n number of disks are there. So you need to know how many disks are there. So either one, two, three, four, any number of disks are there, and you must say which is the beginning pole, which is the auxiliary pole, and which is the end pole. Let's say mark them as A, B, and C. So three poles are there. So this function, as first one, we must know how many n number of disks are there. Then I'm going to take the name of it. You can give you can call it as a beginning, or you can call it as A, or you can call it as EX. It is just the name. Name, you know very well. Name is set of characters. So it is a string and it's a set of characters. So I'm going to take the character array. So let me call this one array, and let's say 5 characters, because we may not like to write a very lengthy name during the examination. So I have three poles there, and the names of three poles. I call them as A, B, C. You can call them with any name that you would like to call. Okay, so these are the A, B, C. Let's go with the first criteria. What is the first criteria? If so, this is the first criteria. What is the first criteria? If there is only one disk, then just move the disk from A to C. So from the source or from the beginning to the end, just move the disk from A to C. This is the luckiest one, that if you get it. So if you get n, that is the number of disks is equal to 1, you are most luckiest person. You just say the solution is, I'm going to just print it because you cannot show the animation over here. So I'm going to say that you have moved from the source to the destination. So move it from the source to the destination. What is why this string is there? Because you know I've taken the name. It's like a beginning, you can take it, or start, you can take it, or simply a any character, or x, any name. It is just a name from the beginning name. Whatever name you are giving, whatever you want to call it as, you call it as. You call it as beginning, you call it as end, you call it as start, you want to call it as stop, whatever it is. So just the name. So from the beginning name, that is from A, you have to move it to the C. Okay, so from A, whatever is the name that you have, let me put a slash in so that it looks great. Otherwise it won't look nice. So slash n, let it come in one line. That is why I'm doing it from A to C. This is the straightforward thing. So if you have only one disk, so if you have only one disk, from A, just move it to C. That's the end of it. So this is very simple. Okay, else now you are in trouble. Okay, else what to do? Okay, so let's try to find the solution. What is the solution? Else you have to go for a, else you have to use the temporary solution. So let's look at the temporary solution. Let's say you have two disks are there. Okay, you have two disks. Okay, so what to do in this case? What to do? You have two disks here. What to do in this case? You cannot simply move the this disk here and then simply get this disk on top of it. It is not allowed, because I already told you we cannot have this is not allowed, because the larger disk cannot sit on top of the smaller disk. That is ruled out. So this solution is ruled out. Okay, so what is the solution then? The solution then is you just take this disk from here, the smaller one, the top one, and put it in the auxiliary. Okay, so you move the disk, one disk from A to the next one. How many disks you have moved? How many disks were there, by the way? How many disks are there? 2 disks are there. So let me write that n is equal to 2 because there are 2 disks are there. How many disks you are moving? You are moving one disk. What is the meaning of saying one disk? You are moving n, which is equal to 2, 2 minus 1, 2 minus 1, which is equal to 1. Why it is n is equal to 2, so it is 2 minus 1, which is nothing but 1. So you have to move, in other words, you have to move n minus 1 disk. Okay, from where? From A to B. Okay, A to B. So you have to move one disk from A to B. But this is if you have only one disk. This story is very good one. What if you have 3 disks? Okay, let me complicate the matter. So if you have 2 disks, then you are in bit 3 disks, then you are in trouble. Now, if you try to move this one here, so n was 3. Remember, n is 3 now. Okay, n is 3 now. Okay, so total number of disks are 3 now. So if you want to move this one, so first to move it here. Okay, so done. Then move this one to here. Done. Okay. Then what are you going to do? Move this one back here. Okay. Remember, it is not violating. You cannot get. Don't do this one now. Don't let me put it in this scenario. You have to do this. I'm going to take 2 disk, this and this, and I'm going to move it. This is not allowed. You can take 2 disk at a time. That is not allowed. Also, I will move this one here, and on top of it, I'm going to put this one. That is also not allowed because you can't have a larger disk on top of a smaller disk. That is also ruled out. So you move one disk to this one, other disk to the other one. Okay, move it back. This is allowed because you have a larger disk on top of it, a smaller disk can fit. There is no problem. Move this one back here. Okay, move it back to this one. Okay, and now these two are in order. Now move this to the other one. So many steps you have taken. So in other words, let's say, in other words, you have 3 disks here. You may have 2, 3, 4, 5, 6, 10, any number of disks. Out of which take suppose if you have n number of disks, I don't know, you may have n number of disks. Out of this n disk, leave out the last disk. Leave out the last disk. Take all the remaining disks. So if there are n number of disks, if you leave one, how many will be remaining? N minus 1. So because you are reserving this one, you don't touch the last one. Remaining n minus disk, any number of disks may be there, 2 may be there, 3 maybe 5, 10, any number of disks, out of which leave the one disk, the last one, leave the last disk. Remaining all the disk, somehow you shift it here, you bring it here, do anything, use the auxiliary disk for temporary adjustment. So first you get it here, then you get it here, then get it back to here, and do something. Do whatever magic that you want to do it, or do whatever tricks that you want to do it. Somehow these n minus 1 disks were there. This n minus 1 disks were there. Take them from here. Remember, not directly by taking like this. If this is not allowed, you cannot directly take them. So somehow using this auxiliary disk, sometime you move it here, then you move it here, then you bring it here, and so on. Somehow by doing some kind of circus, you bring them here and leave the last disk. So that's very important. Leave this last disk. So in other words, out of this n disk, move this n minus 1 disk, n minus 1, remaining n minus 1 disk. You may have many number of disks here. Move this n minus 1 disk to the auxiliary position. Why you have to move them to the auxiliary position? so that the largest disk, the last disk which is their largest disk, is only remaining in this. Okay, when you have this, you have only one disk here, you can easily move them to the other side. So this was my solution. What was the first solution? If you have only one disk, just move them from the source to the destination. If you have only one disk, just move them to the destination. So this is what you are going to do. So leave the last one, remove the remaining n minus 1 disk. So there may be many number of disks may be there. Move all the n minus 1 disk to the auxiliary location. What is the name of this auxiliary location? This one. Okay, using using the C. Okay, so this is what you are supposed to do. So in other words, so somehow you do move them and bring them in this location. So in other words, what I am saying is move all the which one the remaining disk, whichever is there. So this disk. So let me put the last word over here. So move all these disk n minus 1 disk from A to B, okay, using the C. Why did I say using C? Because see, remember, you can directly get this disk directly to the other side. So first you may have to move here, then you may have to move here, then bring it back and do something. So by using the help of C, that is the end, move these two disks to the other side. So this is the meaning. Okay, how do I write that thing? So move this. I'm going to call this same function. So first thing what you are going to do is call the same function. Now, so how do you move this one? To move this one, you have to remember, even though you are simply saying that move these two disks directly from here to here, there is no magic. Remember, at a time you have to bring one. You can't directly bring both of them. At a time you have to bring one, then you have to bring this. Somehow that step I am not interested. I'm just saying that. So get these two n minus 1 disk, move them to the auxiliary, move them to the auxiliary location. Okay. So this is what I'm going to say. So move the disk n minus 1 disk from okay, A to B using the help of C. Remember, what is that I am saying? Move this n minus 1 disk from A to C. This is source to the destination by making use of the C. So in other words, move from A to B. Move from A to B the n minus 1 disk by making use of C. So sometime you may have to put something on here and some other thing on here depending on the situation. So move from A to B using C. So when you do this one, when you move all this thing, what is remaining? Only one disk is remaining. So if there is only one disk is remaining, you know that just move this disk from A to directly to C. This is the largest disk, just move them to the other side. So this you know very well. And there is only one disk, just move it from here to here. And I have already written that story, so I'm not going to type it. When there is only one disk, just move it to the other side. Now the next story will come. What will happen to the these two things? Okay, if you don't want to know the logic, what you can say, move all the disks which are there in okay, move all the disks which are there in B to C by making the help of A. So move all the disks which are here to C. Somehow magically you do it. I don't know how we are going to do it. Magically you move all this straight away. We are saying that. So these disks were here in the intermediate or auxiliary location, move them to the C. Okay, you can't directly move it. So what you can do, you can one disk you can take at a time. You can take one disk, then place one disk in the beginning, move it to this one, then take this one to the other side. Okay, so you got it. So in other words, these two disks were here. I don't know what you're going to do it, but just take them and put them into the other side. Okay, how did you move the disk from here to the other side? By making use of the pole A. By using the pole A, move them to the other side. So remaining disks which were there, n minus 1 disks which were there, move them back from B to C. So from B to C using the help of A. So how do I write this story? I'm going to say move this one. Okay, move the n minus 1 disk from B to C using the help of A. Okay, so this is the story. So move the disk from B to C by making use of A. Now I will tell you the simplest story. Now if I tell this story to a very lazy person, okay, how do you move this one? What the person will say? See, the person will simply say that, see, this one has to come here, right? This one has to come here. So what you can't directly draw them. So see to it that these two, somehow, I don't know how you're going to do it, move them to the middle position, that is auxiliary. So you are now left with the one. Move them here. And what about the remaining? From here, take them and bring them to the other side. Okay, this is what the lazy person would have told. So first, what the lazy person will say is, first, see, the last one has to go. So select the remaining one. First, move them to the auxiliary location. Get the last one, put it here, and then whatever that was there in the auxiliary location, bring them to the here. So am I saying the same story? Yes. So what I'm saying here, look at what I'm saying here is, when you had the situation, let me show the situation here. So let me first get them here to ABC. Let me get them here, ABC here, okay, and ABC here. So what is the first thing that I'm doing? So move from A to C. This is A, B, C. So move from A to B, the remaining, the n minus 1. So take n minus 1 from here, move them to the B location. This is what I said. Okay, move them to the other location. What is left over? Left over is only one disk. Move that disk from A to C. Move that disk from A to C. Move that disk from A to C. Done. And what is the last thing? Whatever that is remaining now, take them and move them to the other four. So whatever that was remaining in the B, move them to C, but make use of the A in that process. So it's as simple as that. Okay. Now this story is good when I'm explaining it. During the examination, this story could be troublesome. So what are you going to do? What is the simplest way to remember this whole thing? Okay. You have this A, B, and C. Okay. So this is the source, this is the destination, this is the intermediary. Okay. For the first time, write the first one, whether it is A, B, C, D, I don't know. Write the first one here. Okay, it may be Z, it may be P, it could be X, it could be anything. Write the first one as it is. Okay, interchange the other two. So in the position of B, get the C. It could be X also. In the position of this one, middle one, get the last one. In the position of the last one, get the middle one. This story. Okay, this story is, I don't have to tell you. This is A to C. True for everything. What about the last scenario? Okay, so let's write again the last scenario. A, B, C. It could be X, Y, Z also. In the last scenario, keep the last one as it is. Don't touch the last one. Interchange the A and B. In the place of A, put B here. In the place of B, put A here. So this was where is this? So this was the B's position. Instead of B, you write A here. Okay. Instead of A, you write B here. So this is simple. So during the examination, just remember, in the first time, you keep the first one fixed, exchange the other two. In the second time, you keep the last one fixed, exchange the other two. That's the only thing you need to do in the examination. So this is done. Let's go ahead. And this is what you're supposed to do it. Let's write the main part for this. This will solve our problem. So let's write the main now. And what are the things that are required? I need to know how many disks are there, that is n. So let me write print f story here, and I'm going to say enter total number of disk. So this disk or disk, okay, no, I am not good in English, so I think that is a disk. Okay, is it k? I don't know. Okay, you ask your English teacher. What is the spelling of that disk? Okay, whether disk or asc? I assume that disc, but if it is if your English teacher says that is different, you ask, follow whatever English teacher says. Okay, but I, what is n? What is n? Total number of disks. So that is what I want. Whether you call it as disc or whether you call it as disk, but I mean to say the same story. What is the next thing that I'm going to do now? If I ask the person that, okay, well, enter the value of n, people will write negative n equal to -1. What is the meaning of saying -1? Means there is no disk. And if I call this function with -1, then because minus of -1, this will not end at all. Okay, so I will just to verify that some people are there. You tell them the straightforward thing, they will trick you, and they will make your program fail. So to handle them, I'm going to say if n is at least one disk must be there. If there is less than one disk, I'm going to say that invalid input. Okay, so what is the meaning of saying invalid input? They also don't know, you also don't know, they also don't know. So when the somebody tries to trick you, you just give an thing that is not understood by them also. So they don't know what is the meaning of invalid input. Let them suffer. Okay, so you are happy. Okay, so let's now write the story printf, and I'm going to say that because something has okay, I'm going to say move the disks disks in this order, okay, /n, so that looks great. And I'm going to call my function. What is my function? My function is tower. This is my function, and I'm going to faithfully pass the value of n. You can do anything. You can make it as a, okay, a, b, and c. Okay. If your examiner says that no, you should write to write like this. If they say that no, you start with beginning, auxiliary, end. It is up to you. Okay. Whatever they call say, you just do it. But first start with ABC, because it is easy to type ABC, is it not? Okay. So you just start with ABC. If your external examiner says that no, you put it beginning, auxiliary, and end, just change the name here. Rest of the program there is no change at all. So the program only you have to just make the changes here. If they say XYZ, XYZ, PQR, PQR. If whatever they say, you just follow it. So your program is already over. Let me save this one, and let me compile it and just see. Okay, how many are there? Suppose if I have only one disk. Okay, so what is my answer? Oh, sorry, this one is not working. Oh, sorry, this is not percentage. This is percentage. You are familiar with the C program. Percentage, yes. So then I think I don't know why I put the dollar there. This is, sorry, this is percentage. Okay, that is percentage, yes, means string it is. Okay. Let me try with the one disk. So if it is one disk, move from A to C. This is the story I already told you. So I won't tell you the step. If it is you have only one disk, what are you going to do? Take this disk and put it to the other disk. You have to say, don't worry about the other one. What if you have two disks? This story is also interesting one. What if you have two disks? So let's look at that one. Press enter, and I'm going to run it one more time. Okay. What if you have two disks? Okay, the order is this one. Let me follow that order and see whether I'm able to get this disk is not there. Don't worry. So let me follow this order. First, what is that thing they are saying? First move A to B. First move A to B. So take this one A, take A to B. Take the top one. Remember, always you have to take the top one, A to B. Then A to C. Then A to C. Done. Okay. Then what is the next thing there? B to C. Have you done that? Yes. So your solution is done. Okay. What about the next story? Let me close this program. Okay. So that is the end of it. Let me run it one more time. What if you have a 3 disk? I will just stop with the 3 disk. These are the steps that you have to follow. If you have a 3 disk, what are you going to do? Let me just show this one. Let's put it here. 3 disk over here. And where is my other disk one? Just let me get that disk first. Okay. I'm going to get that disk. Then I'm going to reduce the size of it so that you can see here. Okay. So done. Let's go with the solution. First, A to C. First, what they say is first one A to C. Put the A to C. Then A to B. I'm doing this one A to B. Second step A to B. So A to B. Next, remember at a time you are only moving one disk. Then what they say is C to B. Then they say C to B. C to B. Done. Okay. Then A to C. Move this A to C. Done. Okay. Then they say B to A, then this is B to A. So B to A, move it to the B to A. Then B to C, so then they say B to C, okay, B to C. And finally they say A to C. Have you done it? Yes. Okay, it is working. That's all you need to do. I'm not going to discuss about this story, even though some of you may be interested in that story. That they will tell you in the theory classes. For the lab, I don't think so. I need to explain that. Thank you for your interest. We will meet again in the other exercise. Thank you.